Next part is to draw a diagram to show the forces acting on the ball when it is in position A. Okay, so fairly straightforward here. I'm just going to draw the ball. We have the force due to gravity there, and then the normal force here because of the boy's arm, or the person's arm. It didn't say, I don't know if it said it was a boy. Anyway, and then we have a force which is the centripetal force, pulling it in, and then we're going to have a reaction force acting on the ball. Oh, wait, hang on a second. Acting on the ball. Okay, so no, there's no reaction force on the ball into the hand. So this is due to, right, so gravity's acting due to gravity. This normal force up here, it's due to the hand, and then this one here is due to the fingers. They're kind of it's being cupped, fingers / arm. So the ball is creating a reaction force on the hand, but there's no reaction force on the ball, right? Does that make sense? I hope it does. All right. Okay, so a student releases the ball and is at A, so it's going to travel vertically upwards, which is 130 centimeters above the ground, and the ball travels vertically upwards. Calculate the maximum height above the ground the ball will reach. All right, so let's write down what we know. Its starting position is 130, so we'll have to add that at the end, 1 meter 30. We calculated earlier that its velocity is 7 meters per second. We know that acceleration due to gravity is going to be minus 9.8 meters. Actually, let me just go back and check. What gravity did they tell us to use? 9.8, good. And then we know that it's going to reach a speed of 0 as it travels vertically upwards. And that's all we need. So we think back to our equations, and the one that links, we want to know distance, right? We don't need to know time at the moment. So we're going to use v squared is equal to u squared plus 2as. And s is what we want to know. V is 0. So I'm going to rearrange this. I'm going to take away u squared on both sides. I'm ignoring the v now because I know that's going to be 0. All right. So that means s is going to be minus u squared over 2a. All right. So go back up here to calculate it. So the displacement, after it is let go, is minus 7 to be squared, minus u squared. Yeah. And I'm going to be dividing that by 2 times minus 9.8. All right, let's do this. So, I can do that. This is minus 49 divided by minus 19.6. I could have really done that in my head. Okay, so the total distance it goes is 19.6, 2.5 meters. Okay, so total height is 2.5 plus the 1.3, so we're going to get to 3.8 meters. Okay, so what time am I at right now? Can I do the next one? 3:42. I'm going to do the next one separately because it might be a bit of a longer one.